Resonance is an conformation, structural conformation. Okay, so what do you mean by structural conformation? It's a change in the structure. So as I informed you yesterday, it's just an change in the arrangement of the bond. So for example, if you are giving the name for this is an 1, 2, 3, there will be an rotation or there will be an changing in the displacement of your bond. Okay, bond in a place ಗಳು change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So there will be a change in the position of the bond. It's not that the bond will break or make. ಇಲ್ಲಿ bond break ಆಗುತ್ತೆ ಅಥವಾ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನುವಂತಹ ಥಾಟ್ ಇಲ್ಲ. We don't have that thought of making or breaking a bond. We just have to know that the position of the bond are going to be rearranged. ಬಾಂಡಿನ ಪೊಸಿಷನ್ ಗಳೇನಾಗುತ್ತೆ ಅದು ರಿಅರೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ನಾವು ಸೆಕೆಂಡ್ ಥಿಂಗ್, ವೈ ಇಟ್ ನೀಡ್ ಟು ರೊಟೇಟ್ ಅಥವಾ ವೈ ಇಟ್ ನೀಡ್ ಟು ಚೇಂಜ್ ದರ್ ಪೊಸಿಷನ್ ಆಫ್ ದ ಬಾಂಡ್. ಬಾಂಡಿನ ಪೊಸಿಷನ್ ನ ಯಾಕೆ ಚೇಂಜ್ ಮಾಡಬೇಕು? ದಿಸ್ ಇಸ್ ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್. ಸೊ ಫಾರ್ ದಿಸ್ ಕ್ವೆಶ್ಚನ್, the position of the bond should change because to satisfy the valency. Okay, to satisfy the valency. For example, if one bond is strict or if it seems to be fix ಆಗಿರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ it should satisfy the valency of the respective atom. ಆ ಒಂದು ಆಟಮಿನ ವ್ಯಾಲೆನ್ಸಿನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಿದ್ರೆ the bond can be restricted. But what is the bond present here inside your benzene that is specifically, or that is the sharing of electron is responsible for all 6 carbon. ಆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು 6 ಕಾರ್ಬನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು. It's related to all the 6 carbon. So if it is fixed to 1 carbon, we can't say that it is restricted only for the carbon number 1 and 2, or it's only restricted for the 3 and 4, like that. We can't say. So because of that, the rotation or the bonds present inside your benzene is keep on moving from one carbon to another carbon to satisfy the valency. Okay, this is my second answer. And next question, how it will form or how it will change the position. It's not like frogs, right? It can jump from here to there, or it's the monkey, like it can jump from one tree to other tree. No, it's not like that. It's not like that. Then how? Yes, then also we need to talk with the valency. Now ಇವಾಗಲೂ ಕೂಡ ಅದರ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ ವೇಲೆನ್ಸಿ ಬಗ್ಗೆನೇ ಮಾತಾಡಬೇಕು. How you will derive it? I'll show you. So suppose leave it. I'll write it like this only because it will be more beneficial to understand. So this is the first position. Okay, this is your first position, like earlier state. What happens? This bond will go and sit upon the carbon. Okay, so it will go on, sit on upon with your carbon. So what happened at that time? This carbon is lost with 1. Howda? This carbon is lost with 1 bond. So it will attaining positive charge. And this gains 2 of its electron. It's in negative charge. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So the bond will exit out from the inside of the benzene ring. So at that time you can see the gain bond carbon containing negative charge and the loosed carbon containing negative charge. ಈ ಬಾಂಡ್ ಇವೆರಡಕ್ಕೂ ಸಂಬಂಧಪಟ್ಟಿದ್ದಲ್ವಾ? This bond is related to these 2 carbon. So what happens when this bond it's completely goes to 1 carbon, another carbon is drawback with the positive charge. So positive charge cation agbidutte. So this is called carbocation. Carbocation. So when a carbon attaining and positive charge is called carbocation. Next, so it's gain negative charge, right? It will send inside. So what happened? This attaining negative charge, this attaining positive charge. Again, what happened? Your bond is not exist here. It will comes here and it will make a bond here. Again, what happened? This carbon here also you can see in this is a normal condition. Okay. So only we are coming like this. So you need to focus on this. This is B remains the same. So now what happened when this carbon gives its energy to inside and it will make the form of double bond in the carbon number 3 and 2. Okay. So what happened at that time? This carbon having more valency like 1, 2, 3, 4, 5, 6. So it can't accommodate those 6 electron. Because the valency of the atomic number of carbon itself 6. So how can it bear a 6 bond? So that's why it will drag out this carbon to himself. This bond will jump to the third carbon. Again, it contains then the charges keep on moving from here to there. So it got negative charge. So what happened? Again, it will send, not this one. This got negative charge. So again, what happened? This will send the bond or the pair of electron to here and it will make bond like this. So now first bond is shifted to here, second bond is shifted to here. Again, it contains here. It's a normal bond. So again, this electron will receive here. It got negative charge. So the negative charge again sent back to inside and it will form like this. So when it's sent back, this become a carbocation, right? So this carbocation will receive and bond electron. It will become neutralized and the charge has been removed. This is called resonance structure. So you have 4 resonance structure in your benzene. So just when the logical answer you can say that, you can see my screen, right? Can you see it now? Okay, write it down. So what I'm saying here means one carbon containing plus charge, one more carbon is minus charge. So the minus carbon will keep on transferring that one bond of electron to its own axis. I'll repeat, no problem. The screen can't style that's actually a problem. I'll do something. Yes. Now, this is your benzene structure. Okay. So what happened? Just give me a second. Okay. So can you able to see my screen? Fine. So now, ನೋಡಿ ಇವಾಗ this is your benzene structure, okay? So this two like VV structure is indicating your H hydrogen presence. So this contain hydrogen. So now what happened? The original structure of your benzene is like this. Fine. So in this structure, to satisfy the valency, or this bond is not completely depend, or it's not correlate only for the carbon number 1. I'll just give a name for this. 1, 2, 3, 4, 5, 6. Okay. Now what I need to do here, this is the 1, 2, 3, 4, 5, 6 carbon, right? So this bond, this is the bond number 1, bond number 2, and bond number 3. This is not only depend for your respective carbons. For example, ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇವಾಗ ಈ ಬಾಂಡ್ ಇದೆಯಲ್ಲ, ಬಾಂಡ್ ನಂಬರ್ 1. ಸೊ ದಿಸ್ ಇಸ್ ಬಾಂಡ್ ಇಸ್ ನಾಟ್ ರೆಸ್ಟ್ರಿಕ್ಟೆಡ್ ಓನ್ಲಿ ಫಾರ್ ಕಾರ್ಬನ್ ನಂಬರ್ 1 and 2. ಈ ಕಾರ್ಬನ್ 1, 2 ಗೆ ಮಾತ್ರ ಸಂಬಂಧಪಟ್ಟಿದ್ದಲ್ಲ ಈ ಬಾಂಡ್. ದಿಸ್ ಬಾಂಡ್ ನಂಬರ್ 1 ಈಸ್ ಆಲ್ಸೋ ಬಿಲಾಂಗ್ಸ್ ಟು ಆಲ್ 6 ಕಾರ್ಬನ್. ಸೊ ಇದು ಎಲ್ಲಾ 6 ಕಾರ್ಬನ್ಗಳಿಗೂ ಸಂಬಂಧಪಟ್ಟಂತಹ ಬಾಂಡ್. ಸೊ ಟು ಸ್ಯಾಟಿಸ್ಫೈ ದಟ್, ಆರ್ ಟು ಡೂ ದಟ್, ವಾಟ್ they'll do, they'll just ask him to rotate. ಹೇಗೆ rotate ಆಗುತ್ತೆ? It will just move out. So second carbon ಹೋಗುತ್ತೆ. This bond will move out to the second carbon. So when it move out, this carbon is less back with the valency. ಕಡಿಮೆ ಆಯ್ತಲ್ವಾ ಒಂದು ಬಾಂಡ್ ಇವಾಗ. So at that time it attaining positive charge. So positive charge ಬಂತು. So it gain ಆಗಿದೆ ಅಲ್ವಾ. So if it is gains of electron, it got negative charge. So ಯಾವ ಕಾರ್ಬನ್ ಈ ಬಾಂಡ್, this bond is related for carbon number 1 and 2 to satisfy the valency. But ಯಾವಾಗ ಈ ಬಾಂಡ್ ರಿಮೂವ್ ಆಗಿ ಆಚೆ ಹೋಗುತ್ತೋ, at that time what happened, your carbon number 1 is filled with positive charge. This positive carbon is called it as carbocation. Okay, this positive charge is called as carbocation. So what happened, this second carbon, so it receiving the, so bond containing 2 electrons, right? So 1 electron is belongs to carbon number 2 and 1 electron is belongs to carbon number 1. So it gains all 2 of its electron. ಎರಡು electron ಅದು ಪಡ್ಕೊಳ್ಳೋದ್ರಿಂದ what happen, it gains with a negative charge. So this is called anion. Okay, anion. So when this electron or a carbon getting a negative charge, it can't bear that electron. 1, 2, 3, 4, 5, 6 electrons, it's more with that. So ಯಾವಾಗ 6 electron ಜಾಸ್ತಿ ಆಗುತ್ತೋ, it will send that electrons to inside and it will make a bond. So the bond formation is like this. So when it send, so ಯಾವಾಗ ಅದು ಹೊರಗಡೆಯಿಂದ ಒಳಗಡೆಗೆ ಬಾಂಡ್ ಅನ್ನು ಕಳಿಸುತ್ತೋ, it will be like this. So as usual, second bond is present here and third bond is present here. We are only disturbing the first bond. We are just rotating the first bond. So at that time what happened, the negative charge of this carbon will neutralize and this negative charge will release. But it got negative charge. Why? Because one carbon having 6 electron, because usually it having 2 hydrogen here, here also double bond, here also double bond. So it can't bear that. So what happened, this carbon will remove the bond and it will send outside to the carbon number 4. So carbon 4 ಗೆ ಅದನ್ನ ಕಳಿಸುತ್ತೆ. So now carbon 4 having a negative charge. So again in madutte carbon number 4, it will send inside. So I can't bear the negative charge, so it will send inside. So avaga enagutte, at that time the specific one bond is here, and the change its position from here to here, it transfer one more bond. Okay, so the second bond exists, but still it having a problem. It got negative charge because of the two double bonds in the one carbon. Again it will release out. So until and unless that it having positive, idra hatra positive charge idde ide, the first carbon. Okay, then again the sended bond will release out here, here, and from here to inside it will move and it will make a bond. So can you just compare the position of the bond from here to here? It's from 1, 2, 3, 4 and 5, 6, but it is from 2, 3, 4, 5, sorry, 2, 3, 4, 5, 6 and 1. So these are the 4 structure of your benzene. It will give you resonance. By giving the one of the bond, this carbocation become neutralized and it will release out its charge. So this is called resonance structure of benzene. Okay, artha aitapa? Can you able to understand? Sorry. Can you able to understand? It's just a concept of removing one bond and it become cation. Sorry, anion. So ಮತ್ತೆ anion ಒಳಗೆ ಕಳಿಸ್ತೀವಿ, ಮತ್ತೆ ಅಲ್ಲಿ ಬಾಂಡ್ ವೇಲೆನ್ಸಿ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಬಾಂಡ್ ಆಚೆ ಬರುತ್ತೆ, ಮತ್ತೆ ಆ ಬಾಂಡ್ ಒಳಗಡೆ ಹೋಗುತ್ತೆ, ಮತ್ತೆ ಇನ್ನೊಂದು ಬಾಂಡ್ ಆಚೆ ಬರುತ್ತೆ. ಇಟ್ಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಟು ಅಂಡ್ ಫ್ರೋ ಮೋಷನ್. ಒಂದು ಹೋಗುತ್ತೆ ಒಂದು ಬರುತ್ತೆ, ಒಂದು ಹೋಗುತ್ತೆ ಒಂದು ಬರುತ್ತೆ. ಘನ ಅರ್ಥ ಆಯ್ತಾ? ಕ್ಯಾನ್ ಯು ಏಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಘನ? ಓಕೆ, ವೆರಿ ಗುಡ್. ಫಾರ್ ಅದರ್ಸ್ ಯಾರಾದ್ರೂ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತ ಇದ್ದರೆ ಇನ್ನೊಂದ್ಸಲ ಕೇಳಿ ಪ್ಲೀಸ್, because this concept is very important. Now you need to draw it for okay. So now ನೀವೇನ್ ಮಾಡಬೇಕು, you need to draw the resonance structure for O3. O3 resonance structure ಬರಿಬೇಕು. So O3 means ozone layer. ಹೇಗಿರುತ್ತೆ ಅದು ಬಾಂಡ್? It will be like this. One side double bond, one side single bond. So this is structure of O3, that is ozone. Just give a resonance of it. ಈಗ resonance ಮಾಡ್ತೀರಾ ಇದಕ್ಕೆ? So nothing, you need to change the position of the double bond from here to here. Will you do it? Nothing here, it's just see the bond of presence bond is here. Just see here ಬಾಂಡ್ ಇಲ್ಲಿದೆ ಅಲ್ವಪ್ಪ, ಈ ಬಾಂಡ್ ಫಸ್ಟ್ ಆಚೆಗೆ ಹೋಗುತ್ತೆ. ಸೊ ಹಾಗೆ ನೆಗೆಟಿವ್ ಮೈನಸ್ ಬರುತ್ತೆ. ಸೊ ಮೈನಸ್ ಇದು ಇಟ್ಕೊಳಕ್ ಆಗಲ್ಲ ಅಲ್ವಾ, ಸೊ ಇಟ್ ಕಾಂಟ್ ಬೇರ್ ಅ ಮೈನಸ್ ಚಾರ್ಜ್. ಮತ್ತೆ ಇದನ್ನ ಒಳಗಡೆ ಕಳ್ಸುತ್ತೆ ಬಾಂಡ್ನ, ಅವಾಗ ಇದಕ್ ಮೈನಸ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಆಗ ಮತ್ತೆ ಈ ಬಾಂಡ್ ಅನ್ನ ತೆಗೆದು ಇದು ಆಚೆ ಕಳ್ಸುತ್ತೆ, ಮತ್ತೆ ಅವಾಗ ಇದಕ್ ಮೈನಸ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಸೊ ಅವಾಗ ಇಲ್ಲಿರೋ ಬಾಂಡ್ ತೆಗೆದು ಇಲ್ಲಿಗೆ ಕಳ್ಸುತ್ತೆ, ಮತ್ತೆ ಅವಾಗ ಈ ಬಾಂಡ್ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಅಂದ್ರೆ ಆಚೆ ಹೋಗುತ್ತೆ ಇಲ್ಲಿಗೆ 6th ಕಾರ್ಬನ್ಗೆ, ಮತ್ತೆ 6th ಕಾರ್ಬನ್ ಇಂದ ಒಳಗಡೆ ಬರುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ಈ ಬಾಂಡ್ ಆಚೆ ಹೋಗುತ್ತೆ, ಆಮೇಲೆ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ಮತ್ತೆ ಆಮೇಲೆ ಈ ಬಾಂಡ್ ಆಚೆ ಬರುತ್ತೆ, ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ಮತ್ತೆ ಈ ಬಾಂಡ್ ಆಚೆ ಹೋಗುತ್ತೆ, ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. ಸೊ ಇಟ್ಸ್ ಜಸ್ಟ್ ಚೇಂಜಿಂಗ್ ಇನ್ ದ ಪೊಸಿಷನ್ ಬೈ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕ್ಯಾರಿಯಿಂಗ್ ಆಫ್ ದ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ನ ಕ್ಯಾರಿ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಆ ಒಂದು ಇದನ್ ಮಾಡ್ಕೊಳುತ್ತೆ ಅಷ್ಟೇ. ವಾಟ್ ಟು ಸೇ, ಇಟ್ಸ್ ಜಸ್ಟ್ ಚೇಂಜಿಂಗ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್. ರೀತು ಮರ್ತ್ಬಿಟ್ಟೆ ನಾನು, ನೀವು PCMB ನ PCMC ನಪ್ಪ? ಓಕೆನಾ? ಓಕೆ, ಬರ್ದ್ರಾ? O3 ಸ್ಟ್ರಕ್ಚರ್ ಬರ್ರಿ. ಫಸ್ಟ್ ಅದು ಬರೆಯಕ್ಕೂ ಮುನ್ನ ಯು ನೋ ದ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್, ರೈಟ್? ಸೊ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಬರ್ಕೋಬೇಕು. ಸೊ this containing 2 electron, this containing 6, ಇದು 4. ಸೊ ಈ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ನ ಚೇಂಜ್ ಮಾಡೋದ್ರ ಮುಖಾಂತರ you need to write it. ಬರ್ದ್ರಾ? Finished? Okay.